Namaskar दोस्तों, welcome back to VNP networking tutorials. In today's video, we are going to understand MD5 hashing in a very simple and practical way. We will start with the basics. What exactly is MD5 hashing and how is an MD5 hash generated? And finally, we will connect these concepts to networking and see how MD5 based authentication is used between Cisco routers for BGP authentication. So, if you are working with BGP or Cisco networking or network security, this video will help you understand what is happening behind the scenes. So let's get started. Now, let's understand what exactly MD5 hashing is and how it works. MD5 stands for Message Digest Algorithm 5. It is a cryptographic hash algorithm or a function that takes an input of any length and produces a fixed size 128-bit hash value. The important thing to remember here is any input when we supply to MD5 algorithm, it will generate a 128-bit hash value. It really doesn't matter whether the input is one character, one word, a complete sentence, or a kind of password, or even a large paragraph. The output from MD5 algorithm will always be a 128-bit, which is represented as a 32 hexadecimal characters. Let's understand this with an example. Now you can see a topology or an image which is representing the MD5 hashing mechanism. In the step 1, you can see that we have a very clear text as an input. The input is admin@123. Please note that the admin starts with capital A. If you provide capital A, admin123, or you provide small a, admin@123, that will generate two separate hash value. The clear text input in the step 1 is supplied to MD5 hash algorithm in the step 2, and you can see in the step 3 MD5 hash output. You can see 32 characters of hexadecimal value, which is the unique value generated for the input we provided. Now, if you change any character in the original input, for example, if you put small a instead of capital A, it will generate a different hash value, entire different hash value. If you put either dot or space or change the number, you will see that the MD5 value is complete a different one. We will see that in a more practical way. So the key points to note that MD5 always produces a 128-bit, which is represented as 32 characters of hexadecimal for the hash. Same input always gives the same hash value. No matter which algorithm you are using or which portal or website you are using, if you try to generate MD5 hash value for a specific text, you will always find the same unless there is a change in the original text provided. Even a small change in the input produces a complete different hash. So be very careful when you provide the input as a text. These are very case sensitive. It will also include a dot, a space. If you put anything like this, it will generate a different value. So in the example, you can see that our clear input text was capital A DMIN@123, which is admin@123, and the corresponding MD5 hash value got generated. Also, please note that the original input contains 9 characters in the admin@123, but the output is always 32 hexadecimal characters, which is represented as a 128-bit. Now let's compare the MD5 hashing for few passwords. For example, the first password shows admin@123, where the A is capital in the admin, and the second password is also admin123 where the character A is small. Please compare these two hash. You can see that those are entirely different hash values. For capital A admin, it starts with EA and ends with E9, the hash value. And for small a admin @123, you can see that the hash value starts with 03 and ends with E3. The only difference between the password is capital A and small a. You can see that even a single character, whether it's a case sensitive or a space anything, it can generate a separate hash value. The third password, if you see carefully, we have a small dot. Okay, the admin @123 starts with small a and ends with a small or with a dot. If you compare the second password and the third password, the only difference is a dot. But if you see the hash value, it's entirely different value. For the dot one, you can see that it starts with 2a and ends with BD. Okay, so this example clearly shows that the password or the string, the clear text string are case sensitive. If you have a small character or a capital character, it will generate a separate hash value. Even if you put a small dot, it will change the entire hash value. Now let's look at some live example for MD5 hash generation. You can go to MD5hashgenerator.com website, and there you will see this section MD5 hash generator. In this blank portion, you can type the text value. So for example, I will use capital A D M I N @123 and you can click this generate. Okay, so you see this, it has generated this value MD5 hash value. Okay, I will copy this and put it in a notepad. Okay, now I will just change the original string from capital A to small a. Okay, small a D M I N @123. I will click generate. So it generated a separate hash value, completely different value. Let me put it here and you can then compare. Okay, see this. The first one was for admin @123 and the second one is admin @123. Okay, now I will do one more trick. I will just put a small dot. Okay, I will just put a small dot after 3 and I will try to generate one more time. Okay, so we have one more hash generated. Let's copy it. Okay, now this is admin @123 dot. So you see that the 3 hash got generated for the admin where A is capital, then admin @123 where is small, and one where we have a dot. So what if I put some string? Okay, let me put some string. Okay, I can put hello, welcome to VNP networking tutorials. Okay, and let me put a generate. Okay, it has now a new value generated. So you see this. This was for my string. So I hope that you have a clear understanding of how a clear text gets MD5 generated with the help of MD5 algorithm. Now, you may be wondering, why do we say that MD5 produces a 128-bit hash? Normally, a bit can have a value of either 0 or 1. So, 128 bits mean that MD5 algorithm produces a sequence of ones or 0 containing total 128 binary bits. For example, conceptually, it could look like something. Here in the topology or here in the diagram, you can see that we have binary bits represented as 1010 1100 0111010 and so on. And this will continue until we have total 128 bits. But displaying 128 binary digits isn't very simple or very convenient. So we normally represent the result using hexadecimal notation. You might further ask, why 32 hexadecimal characters? Because now there are 16 possible hexadecimal values, which starts from 0 to 9, means that covers the numerical, and alphabets you have A to F. So if you count 0 to F, that are total 16 possible values we have in the hexadecimal characters. Each hexadecimal character represents 4 bits. For example, you can see the character A. The character A normally represents a value of 10. So the 10 is represented as 1010. So A is represented with total 4 bits to represent a value of 10. A means 10. Since each hexadecimal character represents 4 bits, therefore 128 bits divided by 4 bits is equal to 32 hexadecimal characters. That's why an MD5 hash is normally displayed as a 32 character hexadecimal string. MD5 authentication. The important thing is that the original password is never transmitted. An example of MD5 authentication is the BGP. For example, if you are forming eBGP between two routers, we have router R1 and router R2. And if you are trying to form the BGP between them, so how R1 will trust that R2 is a genuine router with which I should be forming the BGP? So by default, there is no security. Okay. So you can use the MD5 authentication between the BGP routers forming the BGP neighborship. So in this case, the password is never transmitted. So you will say that if the password is never transmitted, how the BGP will authenticate with each other? Because instead of transmitting the password, only the hash value is transmitted. Okay, as you have seen that any clear text can be converted to a hash value using the MD5 authentication if you configure the same password. For example, Cisco @123. You have configured this password on R1 and you have configured this password on the R2. So these passwords will never be transmitted over the network between R1 and R2. Okay, only the hash value of the password along with the BGP packets. Each BGP packet will get authenticated. Okay, and these hash values are sent in the TCP segments. You know that BGP normally works on the TCP port 179. So this hash value is sent in the in the TCP segment. Okay, so the passwords are never transmitted, and with the hash value, if they are matching, the BGP peers can authenticate. In the next lecture, we will be performing the GNS3 lab, where I will provide you more details of this. The next important point is that you cannot convert an MD5 hash back into original password. For example, admin@123, if you provide this to the MD5 algorithm, it will generate a hash value. But if I give you the hash value and ask you to tell me what is the original text, so that is not possible. Please note. Okay, that is not possible in the MD5 hash value. From clear text, you can generate the MD5 hash, but from the MD5 hash, you cannot generate the clear text. Okay, so in this lecture, we understand the basic of MD5 hashing, how the MD5 hash is generated. In the next lecture, we will see how MD5 authentication is used between BGP peers and understand how the authentication works. We will also perform a hands-on BGP lab, configure MD5 authentication between two routers, and verify the results. So stay tuned for the next lecture. Thanks for watching and see you in the next video.